Hi, my name is Callie Wilson, and this is my Physics 2212 Lab 2 Charge Tape Revisited. For my introduction, in this lab, a model of the experiment from the previous lab will be created where the charge tape is divided into multiple lines of charge. The purpose of this lab is to compare the electric force from the model in the previous lab, which was the point charge, to this model, which is lines of charge. This lab will showcase the principles of Newton's second law, Coulomb's law, and the law of gravitational force as the previous lab did. Each tape's charge was calculated as 2.332 times 10 to the negative ninth coulombs in the point charge model and 1.04 times 10 to the negative 8 in the lines of charge model. The computational model was GlowScript, and the experimental model was our physical experiment. Initial conditions, the tape mass is 2 times 10 to the negative fourth kilograms. The system is a suspended piece of tape, and the surroundings is literally everything else. Continuing the introduction, we'll be using Newton's second law. A system's change in momentum divided by change in time is equal to its net force. Coulomb's law, which describes the calculated electrostatic force between two charged particles at rest, and gravitational force, which describes the force of mutual attraction between two objects with mass. And you can see all the equations to its right. My lab one results are here. So essentially, tape mass, I'd already told you, tape width is 0.02, tape length 0.2, tape distance 0.005, and the charge on each piece of tape, as I said before, was 2.33 times 10 to the negative 9 coulombs. And there's my computational model. My calculations for this experiment, the gravitational force, I got 1.962 times 10 to the negative third newtons. And then for my electric force, I got it equal to my gravitational force. And then my electric charge, I used the usual equation, and I got that it was 1.04 times 10 to the negative 8 coulombs. Now here's my GlowScript. If we start all the way in the left corner, we can see UFPES, which is the constant, and G for gravity. And then we have the mass of the tape, like all the same things that I used in the last computational model will stay the same since the tape stays the same. None of that changes. Now, continuing, we have my electric field calculation with the charged particle observed location. I created this function per usual. And then we have the line charge. Now this is important because it differentiates it from the last model where we assumed it was a point charge. Now we are making it distributed, assuming that everything has a charge instead of one point. Like there's multiple different charges. So that's the function I built here. Top tape, bottom tape, E-scale, so I can properly project the lines off the tape in this model. And then here's the rest and the arrows I built for it. Now here's the results from my model. GlowScript, as you can see, each line are the charges coming off of my tape. And you can see the gravitational force calculated right here, which is 1.962 times 10 to the negative third, and my electric force, which is 1.88468 times 10 to the negative third. Now, my results. Some assumptions we made was that like air resistance and friction are negligible. We assumed that the same amount of charge is on the same piece of tape. We also assumed that each piece of tape has an equal amount of evenly distributed charge. But it seems like there are a few sources of error here that needs to be taken into account. Unequal distribution of charges in reality means a different answer from the computational model and what we had last time with our physical model. We neglected to think about the loss of charge to the surroundings and measurements such as distance and length being off by solid amounts. Now, for our what if questions, what if each piece of tape was modeled as a point charge? How does it compare to the line charge model? Well, the point charge was Q equals 2.33 times e to the negative ninth coulombs, and then the line charge was 1.04 times 10 to the negative eighth. So that's pretty different, at least by like a 10th place. So That's how they compare. And then why do the estimates of the electric charge in each model differ, and which is closer to the actual value? So the estimates are different from one another due to the different methods of calculation as well as possible errors, and one method being more precise than the other. And the line charge model is more accurate as it finds the charge of the tape as small segments that can account for the length of the tape rather than just like a single point.